The rule of associativity says is about associating, really, as the name says. Associativity, what you're doing is you're now associating binary operations within a longer equation or a longer operation. 3 plus 2 plus 4 plus 5. 2 plus 3 plus 4 plus 5. When you associate, you're basically saying you want these ones to be seen as if they are one thing. You do that by putting them in brackets and giving them precedence. If you remember the PEMDAS or BODMAS, whatever is inside the brackets is done first. It's associated, it becomes one. So we are saying here again that addition and multiplication are associative because they display this property, whereas subtraction and multiplication are not. We prove it by making different associations. Here we have 2 plus, and then in brackets 3 plus 4 plus 5. So what this means is that you do the 3 plus 4 plus 5 first, 2 plus, and then 3 plus 4 plus 5. 3 plus 4 plus 5 are associated, they're put there together. So what this means is that you do, by the PEMDAS or BODMAS rule, you do the 3 plus 4 plus 5 first, which is 12. So you'll then have 2 plus 12 is 14. The second one says you do the 2 plus 3 first, and then everything else. So 2 plus 3 that gives you 5. This was associated. And then you add that 5 to 4 and then to 5, you get 14. The third one says you do the 3 plus 4 first. 3 plus 4 there is 7. So then you're going to say 2 plus that 7 that you got there is 9. You add that to 5, it gives you 14. And the last one says you do the 4 plus 5 first, which is 9. So you're going to say 2. So you're going to say 2 plus 3 plus 9. This should also give you 14. So this is how we prove associativity with addition. With subtraction, as I said, you just need a minimum of 2 where the answers are different. If you get any 2 where the answers are different, that is sufficient to disprove. However, you may just want to go through all of them here, where we are going to start off by saying the second one, 2 minus 3, that's negative 1. And then you subtract 4 from negative 1, you get negative 5. You subtract 5 from negative 1, you get negative 10. The third one there, we start with what's in the brackets. That is 3 minus 4, that is negative 1. So you have your negative 1 there. Then you say 2 minus negative 1. 2 minus negative 1 means 2 plus 1, that is 3. And then that 3 minus 5 gives you negative 2. Then finally we have the 4 minus 5. You start with that first, that gives you negative 1. Then you say 2 minus 3, that's negative 1. You have that negative 1 minus that other negative 1 there. So you see it's minus negative, that's plus. It's negative 1 plus 1, 0. QED. Now, an important thing to remember when proving associativity is you should not, under any circumstance, commute the numbers. The numbers or the operands should remain in the very same order. If you shift the order of the operands, you are now creating a situation where you are testing both commutativity and associativity at the same time. And that results in a failed test, a failed experiment, because you are not able to actually test a single thing. The idea here is you're supposed to just test a single thing. So always when you're trying to prove your associativity, make sure that you do not change the position of the operands. They remain in the same place. Only change their positions when you're proving commutativity. Associativity there, you have it, 3 times 4 times 5. That is what, 60. I get it. So you're going to say 2 times 60, that gives you 120. Second one there is 2 times 3, that's 6, times 4 That is 6 times 4, 24. Multiply that by 5, it gives you 120. The third one says you start with the 3 times 4, which is 12. Then you'll say 2 times 12 is 24, times 5 is 120. And then the last one there, you start with the 4 times 5, which is 20. So you'd say 2 times 3, that's 6, times 20, it's 120. QED. So we see associativity there agrees with multiplication. Then finally with the division there, remember you don't change the position of or the sequence of the numbers. What you simply do instead is you change the position of the brackets. The first one there, 24 divided by 6. Then after getting the answer of 24 divided by 6, you divide that again by 2. 24 divided by 6, we see there is 4. Then you divide that 4 by 2, you get the answer being 2. In the second example, the brackets are around 6 divided by 2, so you do that first. 6 divided by 2 is 3. So you'd have then therefore 24 divided by 3, which gives us 8. So we see the answers are different.